All right, gang, tonight we're going to talk about VLANs. Specifically, we'll discuss VLAN segmentation and implementation. We'll talk about security and design, and then I'll give you a little bit of a summary on VLANs. So our objectives in this chapter are to explain what VLANs do for us. We're going to analyze how a switch forwards frames based on VLAN configurations, very specifically in a multi-switched environment. Now you can use VLANs even if you just have one switch, but there's really not much of a reason to use a VLAN with a single switch unless you're doing it for security. We'll talk about how to configure a switch port on a VLAN. Since VLANs generally are going to involve multiple switches, we'll talk about very specifically how to set up what's called a trunk port. And basically, a summary, that trunk port will have multiple VLAN data going out of it. We'll talk about dynamic trunk protocol, which is something that's used with VLANs. We'll talk about some VLAN configurations, and we'll talk about best security practices for a VLAN environment. All right, so what is a VLAN? A VLAN is essentially, they describe it as a logical partition on a layer 2 network. Essentially, VLAN stands for Virtual Local Area Network. And these are partitions that you make in your network that act as completely separate networks. Each VLAN is its own broadcast domain, usually within its own IP network. And that's important. They're mutually isolated from other VLANs in that they only pass data through a router. So, you know, we talked about originally with hubs, we had a single collision domain. Then we went to a switch and each port was its own collision domain. Well, now when we group ports into VLANs, we make them their own broadcast domain as well. And they happen at layer 2, so they're MAC address based. The partitioning of the layer 2 network takes place inside of the layer 2 device, such as a switch. And hosts grouped within a VLAN are unaware of the fact that they're in a VLAN or that other VLANs exist. So you don't have to do anything on the computers to make this work. You do things specifically on the switches to make it all work. So here they're giving an example of a VLAN. And the reason that this slide is important is to note that with VLANs, the computers that are in the same VLAN don't have to be in necessarily the same place. Here they show like a 3-floor building, and VLAN 2 has machines on each floor as well as the other 2 VLANs. It's not uncommon for places that have, you know, like say banks, to group people that do the same job function even though they may not be in the same area. If you are a very large bank, for example, and you're in a skyrise, maybe you have people that do loans. Most of them are on the 1st floor, but some of them are on the 30th floor, 31st floor. Well, VLANs allows you to put those machines that are 30 floors away or wherever into the same grouping so that it looks like one local area network to devices on the network. This means that if I had a printer in that VLAN on the 1st floor and I wanted those people to be able to print to it, they'd all be treated like they were in one network. Generally, we think about VLANs as being things that are in one area, but in truth, because we can add VPNs to it, we can add virtual private networking to a VLAN, it's possible to make VLANs that span all the way across the country. Maybe you are a huge bank with multiple branches and you want all the finance people in one VLAN, but they're in 5 or 6 different branches or whatever. That's easy to do with VLANs. So the benefits for security is kind of the #1 thing. There are lots of other reasons to do VLANs, but the thing that I was always taught was that a VLAN is the best thing in the world for security. Because it makes its own broadcast domains and the other ports aren't even aware of the VLAN, then you add security because they don't even know the other ports are in use or exist. There's a great bit of cost reduction with VLANs. In that earlier example where they showed machines on each floor, Without the presence of VLANs, you would basically need 3 switches for each floor, and those 3 switches would have to be, combined with some sort of trunking so that they're all connected together. Then if a user moved, you'd have to physically go and move their port from one switch to another. They offer performance by shrinking broadcast domains. They say they improve IT staff efficiency. They do to an extent because they make it easier for you to manage a network from a sense of knowing where users are. They also, though, truthfully make it a little bit harder because you have to manage your network a little bit different. And they make it simpler for project and application management. So there are some different types of VLANs: data, default, native, and management. And we'll talk about how Cisco defines each of these. So here we've got a switch. We can log into it. We're logged into the switch. Notice our number sign there, so that tells us that we're in enable mode. We type show VLAN brief, and I'm going to see the VLANs that exist on the switch. And by default, you'll notice that there's one VLAN, VLAN 1, and all of the ports on this switch. This is a 24-port switch, and I can tell that it has 2 gigabit GBICs because of these GI0 and 1 and 2. So all the ports by default are in the first VLAN. That makes it work automatically. Even though you don't do any configuration, everything's in one VLAN, so you don't have anything to have to worry about. You cannot, on a Cisco switch, delete or rename VLAN 1. The default VLAN always exists, and if you were to hard reset a switch, it would put everybody back into that default VLAN. So voice VLANs are a specific type, and this is one of the areas that first started coming around about reasons to use VLANs. VoIP traffic, as most of you know, is time sensitive because it needs to be delivered in such a way that you can respond to it. You often will want to assure that there's a certain amount of bandwidth dedicated to voice traffic. It's common to give that priority over other types of traffic. I've mentioned this to y'all, like on my own network. I have a VoIP phone here at home, and it has priority over all the other traffic. If I'm downloading a file and the phone rings, it's okay if the download slows down a little bit. I want to be able to have good access on the phone. They also mention the ability to be routed around congested areas of the network. If we set up a VLAN properly, we can have it avoid routes that are very busy. Suggestively, and in an ideal world, you want a delay of less than 150 milliseconds across a voice VLAN. The VLAN enables it to carry IP voice traffic from an IP phone. Now they, of course, because this is Cisco, talk about Cisco IP phones. But be aware that basically you could do this with any type of IP traffic. And they say a physical IP phone, but this could also be done with an IP soft phone, like a program on a computer. They mention the Cisco 7960 phone, which we'll talk about. The sound quality of an IP phone can deteriorate if the data is unevenly switched. And one thing that almost all managed switches support now that you will use with voice, whether you do VLANs or not, is called QoS, or quality of service. And that's more about where you're shaping your network traffic. So here we're going to look at one of these entry-level Cisco switches, Cisco phones rather, the 7960. It has 2 RJ45 ports on it. And the reason that it has 2 is that one connects to can be used to connect to your port in the wall, and then the other one can be connected onto your computer. Now I can get into yeses and nos on this. It's available in a general setup. If I'm building a network and there are 2 ports in every room, I'm not going to use the port on the phone, because if the phone, something happens to the phone, I don't want the computer to go down as well. But the purpose of adding that is that in lots of businesses where they get people to switch over, maybe they only have one network port in each of their offices. So this allows you to run through it basically to go out. You'll notice they also show here an AC port adapter. So this one is not running power over Ethernet. And we talk more about power over Ethernet, but lots of places are moving to that because these phones can be powered by it, and you don't need these external power ports for the phones. So here they're just showing to support voice traffic. The port sends a CDP frame to provide the information used by the IP phone, and then the port forwards the frames associated into VLAN 150, which is your default voice port. That automatically allows these to prioritize voice traffic. Now, I've already switched slides, but I want to back up and remind y'all that's just the default. You can change all of that as you go. So something that is rather important to VLANs is called a trunk. And a VLAN trunk basically is just a port that carries more than one VLAN. These are established between switches to allow the information from the VLANs to go to the other switches. With Cisco, they support what is called 802.1q for their trunk protocol. So here we're looking at just a typical setup. I've got 3 switches. I've got, if you notice, they're colored here to show what VLAN they're in. And then they want you to note that the connections here between FO11 and FO1 and then FO3 and FO11 from switch 2 to 1 and then switch 3 to 1 are going to have to be trunk ports. And if they're not configured as trunk ports, what's going to happen is that this data is not going to be able to get from these computers over to these other computers. So the trunk ports allow that to happen. So VLANs can be used to limit the reach of broadcast frames. A VLAN is a broadcast domain of its own, so each one creates its own broadcast domain. A broadcast frame is sent by the device in a specific VLAN is forwarded within that VLAN only. So, for example, just thinking about quick services, if we're using DHCP, we're going to have a DHCP server on each VLAN, because if we only have one and we don't do some sort of DHCP forwarding, then they're not going to be able to get IPs because their broadcast frames are never going to reach the DHCP server. Also, unicast and multicast frames are forwarded within the originating VLAN. This gets important in kind of large places like college campuses, because if you properly set up VLANs, when you do an image, only those machines that are within that VLAN are going to see the image, the multicast or the broadcast traffic going out. So the way that that this works is that for ports to be on a VLAN, they add something called a tag. And a frame tag is the process of adding a VLAN ID header to a frame. It is used to properly transmit multiple VLAN frames through a trunk. The frame tag tells the trunk what VLAN that traffic belongs to. So when it gets to the port or the switch on the other end, it knows, okay, this is VLAN 12, so this data only needs to go to these specific ports because they're in VLAN 12. Switch tag frames identify the VLAN that they belong to. There are many different protocols, but again, we're going to look at 802.1q. The protocol defines the structure of the tagging header added to the frame. So it'll look a little different if you use different ones, but we'll see what this one looks like. Switches add VLAN tags to the frame before placing them on trunk lines and remove the tags before forwarding them through non-trunk ports. That's an important thing for y'all to understand, because that means that only the trunk ports are going to see the tagging information. When that goes back out to a regular port that's got machines on it, that's going to be pulled out. And when properly tagged, the frames can traverse any number of switches via trunks and still be forwarded within the correct VLAN at the destination. We generally think about small networks, but you could have a network with 200 switches on it. And as long as they're all connected together and the proper trunk ports are set up along the path, your data will go from any one of those to any other one of those and stay within the VLAN. So here we've got an Ethernet frame. And if you look at it there, we've added the tag. The tag's going to have the type, which is 2 bytes, PRI or priority, which is 3 bits, and then the VLAN identifier, which is 12 bits at the end. So frames that belong to the native VLAN are not tagged. So if they're in VLAN 1, then it's assumed default. There's no reason to tag it. Frames received untagged remain untagged and are placed in the native VLAN when forwarded. If there are no ports associated with the native VLAN and no other trunk links, then an untagged frame is dropped. And in Cisco switches, again, the native VLAN is VLAN 1. So again, this means if we're not changing anything, if we're just using the default VLAN, then we don't have to do anything. So here we're just looking at another example of a voice VLAN tag using more than one switch. And here they show, the phone will, the switch will instruct the phone to put data into VLAN 150. The 3-port switch is going to be configured for looking for VLAN 150, and it's going to know to send data for 150 out to the Cisco IP phone. So specifically, VLANs have to have numbers, and we're going to look at those. The 2960 and the 3560 series switches support up to 4,000 VLANs. Based off what you're using, what type of equipment it is, the numbers of possible VLANs will vary. For a long time, a lot of older equipment only supports up to 255. VLANs are split into 2 categories. The normal range VLANs are from VLAN 1 to VLAN 1005, and their configuration is stored in the VLAN.dat file in the flash memory. The VTP protocol can only learn and store normal range VLANs. We'll talk about that later. Extended range VLANs are from number 1006 to 4096. These are stored in the running config file. And VTP protocol does not learn extended range VLANs. So again, this is all about how you set it up and how many you really need. I can honestly say I can't come up with an example of anywhere that would need over 1,000 VLANs, but there are probably some places that use it. So there are, it's set up so that it's available. So creating a VLAN, first we're going to do our configure terminal command. We're going to create a VLAN with a VLAN ID number. So we're going to do VLAN space and then the ID. Then we're going to give it a name, and the name is just to make it so that we can keep up with it. Notice the underscores, there's no spaces allowed in the VLAN names. So once we've created a VLAN, then we can assign ports to it. So to assign a port, we're going to do configure terminal. We'll go to the interface ID, whatever interface it is we want to work with. We'll make sure that it has a management IP. We'll set the port to access, so we'll do switch port mode access, and then switch port access VLAN and our VLAN ID. Now, I need to check myself, but if I'm correct, I remember it correctly, the VLAN ID can be by name or it can be by the VLAN number. And once we've done that, we can end to get out of our privileged mode. So here, a quicker way, config terminal, go to the interface, in this case FO18, switch port mode access VLAN 20. So that assigns that port to VLAN 20. And then show VLAN brief will show that I now have a VLAN of 20 created, and it's active. So after I assign a port to it, in this case interface FZA011, and do a show LAN brief, now you'll see down here that it shows FA011 is not in the default VLAN, but now is in the student VLAN. To take it out, you use the no VLAN command. So we'll do a conf T, we'll do no VLAN 20, and then show VLAN brief. Now you see that it's back into our original. When you take a port out, if you don't assign it to another one, it's going to go into 1 by default. Something I'm glad that they've started doing on these slides, because I kind of think it'll help y'all just as you're working through this stuff. As you're playing around with Packet Tracer, remember a lot of these commands can be shortened. Instead of show VLAN brief, for example, here they put SH. Instead of spelling out configure terminal, they're doing a conf T command just to make it a little bit easier. So if you want to show what's on a VLAN by name, you can type show VLAN name and then the name of the VLAN, in this case student, and it would show that there are 2 ports in that VLAN. Show VLAN summary will show us how many VLANs exist. So show interfaces VLAN 20 is going to show the VLAN is up. It's going to tell me information about the VLAN. I could go in and change all of these, but for the most part, we're going to leave the defaults. Like the MTU, we're not going to change unless for a specific reason. And our timeouts. So to enter global configuration mode, remember, configure terminal, then interface ID. To put a port into a trunk mode, you type switch port mode trunk. You can specify a native VLAN for untagged trunks. So if you don't want stuff to go to 1 by default, you can specify if there's not a VLAN ID or tag data, send it to a different one. And that's done with switch port trunk native VLAN and then the number. If I wanted that to be VLAN 2, for example, it'd be switch port trunk native VLAN 2. Then I have to put the list of VLANs that are allowed on that trunk. So switch port trunk allowed VLAN, and then the list of VLANs that are going to be open on that. So down here they show, for example, my trunk is going to run 10, 20, and 30. Based on security settings and how your network is designed, you may have it so that all the VLANs are available on all of the trunks. That way, if you put someone in a VLAN that's out in a different office from someone else, all that data will automatically already be able to go through your trunk ports because it's set up. So taking your switch port out of a trunk is just like the other commands to take them out of VLAN. We're going to go to the interface and we're going to do no switch port trunk allowed and then no switch port trunk native. Once I've done both of those, in the end I can do a show interface and I'll see that I'm back out. So to return that port to an access mode, I would do my interface and then switch port mode access. So here, if I want to verify my trunk configuration, I go to my interface, switch port mode trunk, switch port trunk native VLAN 99. So that means that now I've got VLAN 99 tagged. So DTP is a protocol called Dynamic Trunking Protocol. It is a Cisco proprietary protocol that is used with VLANs, and you're only going to find this on Cisco things. Switch ports can be manually configured to form these trunks. The switch ports can also be configured to negotiate and establish a trunk line with a connected peer. DTP manages that, and it is by default enabled on pretty much most Cisco switches. They keep using the 2960 and the 3560 because those are the common ones, but you're going to find it on almost all the Cisco stuff now. If the port on the neighbor switch is configured in trunk mode that supports DTP, then DTP will manage the negotiation for you automatically. This is actually a pretty great thing because it keeps you from needing to do a lot of setup. So the following trunk modes are available: switch port mode, dynamic auto, and dynamic desirable, then a trunk, and then a no negotiate. So in thinking about VLANs, it is a common practice to associate a VLAN with an IP network. Now, that's interesting, and it's a point to note here. You know, we talk about VLANs. Remember, VLANs actually are layer 2 things. So they don't natively have IP addresses, but we can assign similar IP addresses by putting single subnets on each of our VLANs. And because broadcast traffic is not going to pass through from VLAN to VLAN, and now we've got separate VLANs set up with IP addresses, we're going to have some sort of router for those VLANs to communicate with each other. In their example here, for example, the figure displays that PC1 cannot communicate with the server because it has the wrong IP address. If you're having trouble connecting and you know all the IP address mismatches have been solved, but you still can't connect, check to see that the VLANs exist on each of the switches. So here the way they're doing that is with show interface trunk to make sure the trunks are communicating. Trunking issues are usually associated with incorrect configurations. The most common type of trunk configuration errors are native VLAN mismatches, trunk mode mismatches, or, this is the big one to me, allowed VLANs on trunks. You got to make sure that each VLAN trunk is allowed to carry traffic from that VLAN. If you've got a VLAN tagged and you haven't allowed that data on the trunk, then that, for security, that trunk's just going to delete that data. It's going to wipe it out. So you're never going to get acknowledgments or anything of that data because it's never going to get there. So show interfaces trunk command will allow you to check the trunk ports on the switches. If a port on a trunk link is configured with a trunk mode that is incompatible with the neighboring trunk port, a trunk link fails to form between the two switches. VLANs must be allowed in the trunk before their frames can be transmitted across the link. Like I said earlier, it's going to look at that tag, that 802Q tag, and if it's a bad Q tag, it's going to just delete the data. Use the switch port trunk allowed VLAN to specify that the VLANs are allowed on the trunk. This is why earlier I mentioned it's not an uncommon practice to allow all of the VLANs across all of the switches. And then the show interfaces trunk command to ensure the correct VLANs are permitted. So there are a number of different types of VLAN attacks in modern switch networks. VLAN hopping is one example. The default configuration of the switch port is dynamic auto. By configuring a host to act as a switch and form a trunk, an attacker could gain access to any VLAN in the network. Essentially, there's software, I'm sure there's some for Windows, but I've seen it done with Kali Linux and some other Linux variants, where you plug a computer into a port on the switch. And it takes advantage of everything being set to dynamic by making your computer act like it's another switch that's been plugged in. So it impersonates one of these Cisco switches and asks that information be sent to it about the VLANs. Once it's got the information on the VLANs, then you can start trying to get data off of them, because if you've made your computer look like a trunk port, then the data is going to get sent through it for the ones that are allowed on the trunk port. Because the attacker is now able to access other VLANs, this is called a VLAN hopping attack. To prevent basic switch spoofing attack, turn off trunking on all ports except the ones that specifically require trunking. So this is the way to get around that. If you go in and configure it so that only the port that's needed that actually connects to another switch is the port that the trunk is allowed on, you'll be able to block some of this. Another type of attack on a VLAN is called a double tag attack. And this takes advantage of the way hardware on most switches look at 802.1 Q tags. Most switches perform only one level of de-encapsulation, which allows an attacker to embed a second unauthorized attack header in the frame. So basically what you do in this is you are encapsulating a packet that has an encapsulated 802 Q tag already on it. After removing the first legitimate Q tag, then what happens is it will forward the frame to the VLAN that's got the other Q tag in it. The best approach to mitigating double tagging attacks is to ensure all of the native VLANs on the trunk port are different from the VLAN used on any user port. So if you set a native VLAN for a trunk that's different, you can eliminate this. It really doesn't matter what you set it at. As a general rule, we used to use VLAN 254 for all of the trunking over at LSUS. And that was separate, that was a separate VLAN that wasn't used for anything else. And that VLAN didn't have access to anything else except to send data through to the other switches. So here they're just giving you a graphic example of that double tag attack. So you have one other thing known as a private VLAN. And this is a protected port type of thing that ensures there is no exchange of unicast, broadcast, or multicast traffic between protected ports on a switch. Basically, if you turn this on, then no port is able to broadcast anything to any other port. A protected port does not exchange traffic with another protected port. The easiest way to explain this is kind of like if you turn on what's it called, on a wireless, if you turn on isolation, where the users are allowed to connect through to the to the router or whatever, but they're not able to connect to each other. And there's pluses and minuses to the idea of turning this on. It does allow for extra security, but it sure does make it difficult if devices need to communicate with each other. It can put extra load on a switch or on a router, because in order for the devices to communicate, everything's got to go through your router. So some design practices they suggest. Move all ports from VLAN 1 and assign them to a not in use VLAN. Shut down all unused switch ports. That means, if something's not in use, turn that port off. Separate management and user data traffic by creating a management VLAN other than VLAN 1. Ensure that only devices in the management VLAN can connect to the switches. Here's a big one. Turn off Telnet, turn on SSH. Only allow the switches to accept SSH connection. They suggest that you disable auto negotiation on the trunk ports, and do not use auto or desirable switch port modes. So, quick summary of Chapter 3. We talked about VLANs and their types. We talked about VLAN and broadcast domains. We talked about the Q tagging. And we looked at how these are configured on Cisco. Start